Okay, good morning, Math 8. We are going to sidestep our volume stuff now. I think we're mostly done with that. Might come back to it for one more lesson later on. But we're going to look at a different unit relating our equations and our lines. We can't do a whole lot of graphing virtually, so a lot of this is just going to be more recognition, like looking at stuff we know, and I hope it's going to be virtually, LOL, painless. So we're going to start today with a pretty short lesson, and the exit step's going to be more involved, but I think it'll be really beneficial start for you guys. So we're looking at solving systems of linear equations by graphing. We'll talk about what all those words mean in a minute. So the first step is your family starts a bed and a breakfast. So it's like a hotel. They spend $500 fixing up a bedroom to rent, and the cost for food and utilities is $10 per night. And your family charges $60 per night to rent the bedroom. So we're going to start by writing a couple different equations to model this. The first equation is going to represent the costs. And for the rest of this page, I'm going to try to keep everything about cost in black. And the second equation is going to be about revenue. So I don't know if you've ever heard about revenue before, but revenue is the money that comes in. So like when you go to the store and you buy something, what you pay the store is their revenue. It's not their profit, because that money doesn't go in their pockets. That's just the money that comes in. That's the money that the consumer pays. So an equation that represents the costs is represented by these boxes. So the cost in dollars is $10 per night times the number of nights X. So if it's one night, it's $10. 2 nights is $20, 10 times the number of nights. 10 nights would be 10 times 10 is $100. So that's how much it would cost them, because the bed and breakfast pays utilities. Like they get the bill for utilities, like electricity and water, they get a bill for that. That's approximately $10 per night. And then there's that initial $500 to renovate. So they had to pay $500 up front to, like, I don't know, maybe they had to refinish the floors or buy a bed or do something to that room to get it into a good state. So the equation is then cost equals 10 times the number of nights X plus that original $500. Or you could write it as C equals 10X plus 500. And back in our problem, we can get the 500. They spend $500 fixing it up. And then utilities is $10 per night and food. So they got to pay to feed these people too, right? It's a bed and a breakfast. So maybe the continental breakfast they gave you. And then there's a separate equation talking about revenue. So the revenue, the money that comes in. Well, what money do they make? Well, the revenue is $60 per night times the number of nights, because they make 60 per night. So revenue, if you can see the pink color, right? It looks pretty good. Revenue equals 60 times X. So those are my two equations. My revenue is $60 times the number of nights that have gone by. And the cost is $10 per night plus that initial $500. So we notice that it costs them a lot to get off the ground. Like it costs them a lot at first. But utilities, every night, the hotel has to pay less than they're making. And that's very typical of businesses. Like most businesses have a lot of upfront fees, like buying a building, like getting their name out there. Even patenting a product, it's expensive. So they have to then charge more than their products actually cost them to make, because they have to make money somehow. They have to make back that money. And that's what we're going to be looking for, the amount of time it takes them to make back that money. So our vocabulary that we're going to look at is system of linear equations. And a system of linear equations is very simply more than one equation but it's more than one equation about the same circumstances. So it's with the same variables. By the way, this problem does not come from our illustrative math curriculum. This problem actually comes from the Big Ideas math curriculum. So that's why it's not in our online curriculum. But I think it's a really great way to introduce the unit. So our system of equations, we have our cost equals 10x plus 500. And we have our revenue equals 60x. That is our system. Okay. So on the back, we're going to look and see the long-term behavior of this system. So we have our cost and our revenue. We're going to look at this as a table, just to figure out some numbers. Like after each number of nights that someone stays there, what is the total cost? And what is the total revenue? Sorry, I can't escape my iced coffee swishing, even at home. So the cost, remember, that cost equation was 10x plus 500. And that revenue equation was 60x. So if nobody stays in the room, if nobody stayed there, they still paid that $500. So that's actually my y-intercept. Remember that? Flashback. But if no one stays in the room, their revenue is 0. No one stays there, they don't get any money. But they also didn't pay any money. So cost was 500, revenue was 0. So now if we look back at cost, if one person stays there for one night, their total cost was 500 plus 10. So it's 510. And if someone stays there 2 nights, that's 500 plus 10 times 2 is 20. It's 520. And you can see the pattern. 530, 540, 550, 560, 570, 580, 590, 600, 610. And that 10 is my slope. If I, oh geez, slope, not again, Mr. Roboto. If x goes up by 1, that means my y goes up by 10. For every one night someone stays there, our cost increases by $10. So there's our slope too. It's like our whole year is coming full circle. Isn't it phenomenal? And then my revenue started at 0. But every time someone stays there, I make $60. 1 times 60, oh cool, 60 bucks. 2 nights, awesome, $120. 3 nights is 60 times 3 gets me 180. 4 nights, 60 times 4 gets me 240. And I'm just gonna count by 60s using my knowledge of my 6 tables. It's so sad having nobody to laugh at my jokes in person. It's just so quiet here. All right. So now we want to notice something about the table, and the noticing is coming into play in part B. How many nights does your family need to rent the bedroom before, I'm doing all the wrong things. How many nights does your family need to rent the bedroom before breaking even? So breaking even is like when you've made ends meet. So that's when your cost equals your revenue. I lost my color coding. Sugar plum fairies, I've lost my color coding. Okay. Cost was black. So cost equals revenue. So at what night does the cost and the revenue equal each other? And it looks like my answer is right here at 10 nights. At 10 nights, cost equals revenue. Because after 10 nights, it's cost them $600 to keep this room open, and they've made $600 in revenue. So now they've paid back that $500 initially and all that. And now in the future, their revenue is more than their cost. All right, so now they're making a profit. So we're gonna go ahead and we're gonna plot these points in our graph really quick. So graphing the cost equation, C equals 500 plus 10x, My y-intercept is 500. And my slope was 10, but really I can just plot these points. So after 1, it was 510. 2 was 520. All right, so it's going up a little bit. It's going to be 550. So it's pretty low, pretty low. Well, at 5 nights, it was 550, so I'll just do that. 5 nights, 550. And then 600 was at 10. So there's my line right there. That's a really straight line, Mr. Roboto. That's not bad. So then I'm going to graph my revenue. Our revenue equals 60x. So that one starts at 0. I started with no money, but then after 1, I had 60, so that's a little bit more than 50. And all right, let's plot some easy points. At 5 nights again, it was $300, so I'll just go to 5 and 300. And then at 10, it was 600. Ooh, interesting, same exact point. That'll probably come in handy later. So then I can plot my revenue function as well. So we notice this 10 nights, the break-even point was where the 2 lines intersect. So that's our good learning for the day, is that when we have 2 situations, there's a break-even point where both variables are the same at the same time. The nights were the same, 10 nights, and the cost was the same. After 10 nights, they paid 600. After 10 nights, they'd also earned 600. And on my graph, it's the intersection point. All right, so your exit slip is something very similar. You write an equation to model a situation, and you make a table for each one. There's no graphing, don't worry. I haven't found a good way to make you graph things for me, and we'll see if I ever get that far. And then you have to just sort of say what's your solution point, okay? But I'll tell you, the exit slip is designed so that you don't move on until you get the right answer. It's multiple choice. You won't be stuck there forever, but give it your best try. If you read, there should be little hints for each question, or for most of them. That'll sort of help guide you, all right? It won't let you finish the exit slip to get everything right. That's why it's the only activity for the day, because it might take you a little bit longer if you're still a bit confused. But I think it's going to be really good for you. Let me know in the last